This is Divyasri from Triple Department, and this is my CA2 assignment of second BTech second semester. And my subject name is Control Systems, and my topic is Problems on Polar Plot. First of all, what is polar plot? A polar plot is also known as a Nyquist plot. It is a graphical representation of the frequency response of a system, plotting the magnitude of a transfer function against its phase angle in polar coordinates, where the frequency varies from 0 to infinity. Actually, the polar plot is also known as a Nyquist plot. It is a graphical representation of the frequency and response, and it varies frequency from 0 to infinity. First of all, polar plot, how do we plot a polar plot? Means this is a unity circle. And this is the unity circle. First we have to plot the points, and if the GM is equals to 1 by mod GB, PM equals to 180 plus pi GC. These are the formulas of GM, gain margin, and GM and PM. GM and PM are, if we substitute the pi GC and GB values in the GM equals to 1 by mod GB, PM equals to 180 plus pi GC. If the GM and PM are positive, the system is stable. If in case the GM and PM are negative, the system is unstable. Where the circle, where the line touches the circle up to the y-axis is known as the pi GC. And this is about the another one. GM and PM are negative, system is unstable. As the circle touches the line touches the unity circle up to this pi GC. If the GM and PM are unstable, the negative, the system is unstable. Now we'll see the one problem. Problem 1, a open loop transfer function of a unity feedback system is given below. The G of S equals to 1 by S of 1 plus S into 1 plus 2S. Sketch the polar plot and determine the gain margin and phase margin. Gain margin means GM and phase margin means PM. Step 1 is, for every problem there is a same step 1 plus ST form. First we have to see that here the function is in 1 plus ST or not. Yes, this function is in 1 plus ST form. Now we'll move the second step. Second step, we have to substitute, find the magnitude and phase angle. For this, we have to substitute S equals to J omega. In this, the function is G of S equals to 1 by, G of S equals to 1 by S into 1 plus S into 1 plus 2S. We have to substitute in place of S G omega. 1 by G omega plus, into 1 plus J omega into 1 plus 2J omega. If we have, for finding the magnitude, we have to neglect the imaginary term and we have to find the magnitude only. 1 by omega into root over 1 plus omega square into 1 plus root over 1 plus 4 omega square. In the angle of G of J omega equals to pi equals to, this is the formula, pi phase angle, minus 90 degrees minus tan inverse omega, tan inverse 2 omega. We have to find the corner frequency. Omega C1 equals to 1 by T. In the T, we substitute the 2. It means 0.5 radians per second. Omega C2 equals to 1 by T equals to 1 by 1 equals to 1 radian per second. We have to frame a tabular column, radians per second. This is the magnitude plot. And this is the phase plot. We have to substitute up to, here we got the 0.1. Between these values only we have to substitute, between the values we have to substitute in the phase plot and magnitude plot. We take the 0.35, 0.4, 0.45, 0.5, 0.6, 0.2, 0.8 and 0.1. These values are in between the 0.5 to 0.5 to 1. We will substitute the 0.35 in the phase magnitude plot. We will get the answer 2.2. 0.4, 1.8. 0.45, 1.5. 0.5, 1.2, 0.6, 0.9, 0.2, 0.6, 0.8, 0.5, 1, 0.3. In phase plot minus 144, if substitute 0.35, the phase angle is minus 144 degrees, and 150 minus 156 minus 61 minus 171 minus 179 minus 186 minus 198. From the graph, we find out the GB equals to 0.7, pi GC equals to minus 169 degrees. We will substitute GB, we will get 1 by 0.7 equals to 1.42. PM 180 plus pi GC. Pi GC is nothing but from graph we determine the pi GC as minus 169 degrees. You will get 11. So the PM is positive and GM is positive. So the system is stable. Now we'll see the graph. So this is the polar graph and this is the unity circle. This one. So this one is unity circle and we have to plot the points. In between this, the circle is touches, the face is touches, the magnitude plot is touches here. So up this two and the this is the pi GC. So the PM and GM are positive, the system is stable. So this is about the polar plot and how we learned how to plot the polar plot in a graph. Thank you.